Hello everyone and welcome to the coding channel. My name is Nicola and I'm a software engineer. In this video we're gonna looking at one of the most common coding problems, that is the problem to find out a sum in a given array. It is a quite easy coding problem, but I think that is very useful for understanding how to approach coding question. So let's get started. So the problem say, given a sorted array of integer numbers without repetition, we have to find out all couples where the sum of their digits match a given target number. For example, the array A, composed by the numbers 1, 2, 3, 4, 5, 6, 7, 9, and 10. And our target number is 8. The output shall be the couples 1, 7, 2, 6, and 3, 5. The first approach that we can make is just to try all possible couples of the array. For example, 1 plus 2, 1 plus 3, 1 plus 4, 1 plus 5, and if their sum match the target, we just need to print the couple. When we reach the end of the array with the first index, we just increase the index to the second one, and repeat again, 2 plus 3, 2 plus 4, 2 plus 5, 2 plus 6, and so on. And again, if their sum matches the target, we print the couple. When we reach the end of the array with the first index, the algorithm is finished. Let's take a look at the code. First of all, we need to declare the array and the target number. Then we need two for loops, one for the first index and the second one for the second index. These two for loops allow us to see all possible couples of the array. If the sum is equal to the target, we have found a couple. The algorithm is very simple, but if you take a look at the complexity of the algorithm, we can see that even if the declaration takes only a constant time, the two loops with the for loops and another one have a square complexity. The total complexity of the algorithm is driven by the two for loops, and so it is squared. We can now try a different approach. If we notice that the greatest sum that we can have is the sum of the last two numbers, in our example 10 plus 9 equal to 19, and that in the other hand the lowest number is given by the sum of the first and the second digit 2 plus 1 equal to 3. If we assume that the array is sorted, as said by the problem, it is possible to set a left pointer on the number in the position 1 and a right pointer on the last number, in this case 10. If we make their sum and we see that it is greater than the target number, 10 plus 1 greater than 8, we already know that all other possible numbers added to the number at the pointer right will also be greater of the target number. For example, 10 plus 2, 10 plus 3, and so on. In another way, we can make the same reasoning. If their sum is lower, we already know that all possible numbers added to the number pointed by the left index will be lower than the target number. Finally, the solution is just to decrease the right pointer in case that the sum is greater than the target and increase the left pointer in case the sum is low. When the two pointers arrive at the same position, the algorithms end. If you look at the code, we can see that with this approach we have just one loop respect to the previous algorithm, for the reason that all the complexity is linear. The graph shows the differences between the execution of the first and the second algorithm. As we can see, growing the number of the elements in the starting array, the difference becomes very huge. And what about to try to resolve this problem without a sorted array? Well, first of all, we can easily sort the array and then use the second algorithm. If we consider that the complexity of the faster sorted algorithm quicksort is big O of n log n, and added with the linear complexity, we have a total complexity of big O of n log n, that is lower than the square of the first algorithm. The second solution we can make is to use the hash map. The hash map is a data structure with the particularity to give us a constant access time to a stored number knowing the associated key. So, starting scanning the array, we can take the first number and add it to the hash map as a key. When we jump to another number at position after the first one, we just need to check if in the hash map there is the number as a difference of the target and the number itself. For example, for the number 2, we have to check if in the hash map there is the key 6 obtained by 8 minus 2. And in this case, we can print the couple because we have found it. After this check, we can store the number in the hash map for the keeping memory for other numbers. We can then proceed in this way until we reach the end of the array. Also in this case, the code is quite slim, and as we can see, we have just one for loop that gives to us a linear complexity. All other checks or access to the hash map have a constant complexity. The graph shows the difference between the linear and the big O of n log n complexity. As we can see, the difference is not so huge as the two first algorithms. We can conclude that the last algorithm we have seen could be the correct and more efficient solution to the problem. Okay, thank you guys for watching, and if you have any question or any suggestion, please let me know here in the comments below. Thank you again, and see you soon in the next video.